Good day, everyone. Welcome in physical science. So before we start, we'll be having a free test. So choose the letter of the best answer in each item and write it on a separate sheet of papers. Number one, it refers to the ability of an atom in a molecule to attract shared electrons. A. Electron affinity. B. Electronegativity. C. Ionization energy. D. Electromotive force. Okay, the answer is letter B. Number two, which of the following statements is true about polar bonds? A. They are present in metals. B. They are responsible for the formation of ionic compounds. C. They always result to the formation of polar molecular compounds. D. They may result to nonpolar covalent compounds depending on molecular geometry. So the answer is letter D. 3. What type of chemical bond holds the atoms of water molecule together? A. Hydrogen bond. B. Ionic bond. C. Polar covalent bond. D. Nonpolar covalent bond. The answer is C. 4. Which of the following molecule is nonpolar? A. Sodium chloride. B. Hydrogen chloride. C. Carbon dioxide. And letter D. Ammonia. So the answer is letter C. What is the electronegativity difference between carbon and oxygen? A. 0. B. 0.5. C. 1.0. D. 1.5. The answer is letter C. 6. Supposedly, a hypothetical molecule has an electronegativity difference of zero point 0.5. What is the type of chemical bond present? A. Ionic. B. Hydrogen. C. Polar covalent. D. Nonpolar covalent. The answer is letter C. 7. What is the molecule shape of beryllium trifluoride? A. Linear. B. Trigonal. C. Tetrahedral. D. Trigonal pyramidal. The answer is letter B. 8. A molecule with a polar band is always polar. Molecules consist of polar bands, can be nonpolar. A. Statement 1 is false, while statement 2 is true. B. Statement 1 is false, while statement 2 is false. C. Both statements are true. And letter D. Both statements are false. So the answer is letter A. 9. Which of the following pairs of atoms are bound by a polar covalent bond? A. Chlorine dash chlorine. B. Magnesium dash oxygen. C. Nitrogen dash hydrogen. D. Carbon dash sulfur. Number 9 is letter C. 10. The shape of the molecule is a three-dimensional arrangement of atoms or bonding groups around a central atom. The molecular shape is governed by the valence shell electron repulsion, or this what we call VSEPR theory. So A, the first and second statements are true. B, the first and second statements are false. C, the first statement is true while the second statement is false. D, the first statement is false while the second statement is true. So the answer is letter A. Now, for 11 to 15, write true or false. Write true if the statement is correct. Otherwise, write false. For 11, the electronegativity of elements in the periodic table generally increases as you move from top to bottom of a group. So the answer is false. 12. Fluorine has the highest electronegativity value, while cesium and francium have the least electronegativity values. The answer is false. 13. Water with a bent molecular shape is classified as a polar molecule. The answer is true. 14. Sulfur hexafluoride has 6 bonded electrons and no lone pair in its central atom. The answer is true. 15. Hydrogen cyanide exhibits a linear geometry. The answer is true. Now, today we are going to discuss with you polarity of molecules. So it is interesting to have a quick glance at the lessons you have learned about compounds and chemical bonds when you were in grade 8, 9, and 10. Can you still recall them? If you still do, then that's great. In grade 8, you learned that atoms combine to form molecules or compounds to attain a stable configuration that satisfies the octet rule. On the other hand, you have learned about chemical bonds or intramolecular forces. Its three types, namely ionic, covalent, and metallic, and the writing of Lewis dot symbol in grade 9. In your grade 10 science, you have learned the concept of electronegativity and you were briefly introduced to the topic of polarity of molecules as determined by electronegativity values. Studying this lesson will certainly increase your understanding about the polarity of molecules. This lesson is packed with interesting activities which will make you enjoy your chemistry lessons even more. So, are you ready to dwell on the exciting quest for chemistry learning? Good luck and happy learning. Chemical bonds are formed when atoms lose or accept or share electrons. An ionic bond occurs when there is a transfer of one or more valence electrons from one atom to another. It exists between metal and nonmetal atoms, where metal loses electron or electrons, while nonmetal accepts the electron or electrons donated by a metal. On the other hand, when two nonmetal atoms combine, neither of them loses or gains electrons. Instead, electron pairs are being shared by both atoms, and the type of chemical bond formed is called covalent bond. So remember that non-metal and non-metal is a ionic compound, and metal is a covalent bond. Are you ready? So for our activity, tell whether the compound below is an ionic compound or covalent compound based on the type of chemical bond present. So we have number one, sodium chloride. For number two, calcium oxide, dioxide. Three, okay, calcium chloride. Four, carbon tetrachloride. We have five is iron oxide, or this what we call ferric oxide. With number six is dinitrogen monoxide or a nitrous oxide. We have number seven is a phosphorus pentachloride. Number eight is potassium bromide. Number nine is hydrogen chloride. And of course, number 10 is aluminum chloride. Now, for our answer, we have sodium chloride and calcium chloride. We have also iron oxide or ferric oxide, and we have potassium bromide, and we have aluminum chloride are all ionic compound because the atoms are involved are combination of metal and non-metal. On the other hand, we have carbon dioxide and carbon tetrachloride, and of course, we have dinitrogen monoxide or nitrous oxide, and we have phosphorus pentachloride and hydrogen chloride are covalent compounds because the atoms involved are both non-metals. It's good that you were able to recall the difference between ionic band and covalent band. You have learned that a covalent is a shared pair of electrons between two atoms. But are the electrons equally shared by the combining atoms? How does a polar covalent band differ from a non-polar covalent? Did you know that electronegativity of an atom can be used to further classify covalent bond into polar and nonpolar? As you perform the activity, you will find out the substances have different polarities. And that this explains why there are substances that do not mix while others do. For example, we have lithium and of course you have fluorine. So lithium and fluorine. So lithium has an atomic number of 3 and fluorine has an atomic number of 9. And we're going to have the valence electron of lithium. So 1s2 and 2s1. And the outside state right now is 2s1 and we have 1 value. Therefore, lithium has 1 dot. On the other hand, we have fluorine. We have 1s2, 2s2, and 2p5. And the coefficient value is 2 right now. The excited state is 2 plus 5. So therefore, we have 7 dots. So fluorine have 7 dots. And of course, lithium has 7 dots. Now, in order to complete the octet rule, that we're going to have 8 dots. So if lithium are going to combine to fluorine, so lithium plus fluorine, so what we are going to do, the product is lithium fluoride. All right, so therefore, in this case, lithium has to release one electron, negative electron, while fluorine has to gain one negative electron. Note that the number of electrons fluorine must gain should be the number of electrons lost by lithium. Since the number of electrons of lithium has to release is already equal to the number of electrons that fluorine has to gain, then we can say that we need one lithium atom for every one fluorine atom to form an anionic compound. Therefore, lithium fluoride is an ionic compound. Another example, we have H2, or this is what we call hydrogen gas. Right, the exponent of 2 here is subscript, not superscript, okay? So hydrogen and hydrogen. So we have two hydrogens. So hydrogen has an atomic number of 2. So therefore, the valence electron is 1s1. So the outside state is numbers 1. So therefore, the hydrogen has only one dot. So therefore, if you have two hydrogen, therefore we have two dots. So this is a molecular formation of hydrogen atom and another one hydrogen atom. If we're going to compound, it will be a molecule, and this is what we call hydrogen gas. And this is the octet rule illustration. And where you can we can also use two dots or a single bond. Okay, atoms share the two electrons at the middle. Each atom achieves the electron configuration of the noble gas helium. So the covalent bond represented as dash between the two hydrogen atoms correspond to the two bonding electrons. The dash between the two atoms is called single band. The polarity of molecules is determined by the two factors. The polarity of bands based on the electronegativity difference of the atoms involved and the geometrical shape of the molecules, which can be predicted via valence shell electron pair repulsion theory. Polarity of bands and electronegativity. In your grade 9 chemistry, you have tackled the lesson about periodic properties of elements such as atomic size, metallic property, ionization energy, electron affinity, and electronegativity. Can you still recall the definition of electronegativity? If not, no problem, because it will be defined for you. Electronegativity, or EN, measures the relative tendency of an atom to attract electrons to itself when chemically combined with other atoms. Take a look at the electronegativity values of some elements. Figure 1. What have you noticed? The electronegativity increases from left to right of a period and decreases from top to bottom of the group. Take note also that the higher the value of electronegativity, the element tends to attract electron towards itself. So what is the connection of electronegativity to the polarity of bonds? We could use the electronegativity values of the atoms involved to get the absolute electronegativity difference, which will help us in predicting what type of chemical combine, whether it's ionic, polar covalent or non-polar covalent would exist between them. So table 1 shows the type of bond based on the electronegativity difference of bonded atoms. So like for example, in this figure, we have Pauling electronegative values of some elements. We have hydrogen, we have 2.1, we have lithium 1.0, beryllium we have 1.5, sodium 0.9, potassium 0.8, rubidium 0.8, cesium 0.7, francium 0.7, and so on and so forth. So table 1, type of bond based on the electronegativity difference of bonded atoms. So we have type of bonds. We have ionic, polar covalent, and non-polar covalent. So we have electronegativity difference. So we have here 1.7, 0.5 to 1.6. Okay, we have here less than 0.4. That would be a non-polar covalent value, polar covalent value, and ionic compound value. For example, you are asked to predict what type of bond is present between the following pairs of atoms by determining their electronegative difference. So we have number one, calcium and chlorine, number two, chlorine and chlorine, three, hydrogen and chlorine, four, sulfur and chlorine, and five, we have carbon and nitrogen. So here for number one, we have here electronegativity of calcium based on the periodic table is 1.0. And of course, we have the electronegativity of chlorine, that would be 3.0. So therefore, we have 1 minus 3 is equals to negative 2, meaning, or negative 2 or 2, therefore it's ionic bond. The baseline is 1.7. Actually, the exact value is 1.67. Number 2, we have chlorine is equal to 3.0. Another chlorine is 3.0. Therefore, we have 3.0, okay, minus 3.0 is equal to 0. It's non-polar covalent bond. Number 3 is hydrogen is 2.1 and chlorine is 3.0. So therefore, we have 2.1 minus 3.0 or negative 0.9 or 0.9. That would be polar covalent bond. Number 4, we have 2.5 and 3.5 for oxygen. So we have 2.5 for sulfur and 3.5 for oxygen. We have 2.5 minus 3.5, negative 1.0 or 1.0. That would be polar covalent bond. For number 5, we have carbon 2.5 and we have nitrogen is 3.0. So therefore 2.5 minus 3.0, that would be negative 0.5 or 0.5. That would be polar covalent bond. Using the above examples, let us know more about polar and non-polar covalent bonds. A polar covalent bond is formed when electrons are shared unequally by atoms in a compound. So the bonded pair of atoms to form an electric dipole represented as this one. So dipole means two poles. So which means that a molecule has one positive end and one negative end. So in this type of bond, the atom with a higher electronegativity value becomes, okay, becomes the partial negative pole, okay, symbolized as this one. This is a partial negative pole, while the atom with a lower electronegativity value becomes the partially positive symbol as this. Always bear in mind that the direction of the arrow is always pointing from a more electropositive pole to the more electronegative pole. Take hydrogen chloride, for example. Hydrogen has higher electronegativity than chlorine. Thus, the direction of the arrow is pointing away from chlorine and towards chlorine, pointing away from hydrogen and towards chlorine. There is an equal electron density as represented by a size of a circle. So, on the other hand, nonpolar covalent bond develops if both atoms equally share and a pair of electrons between them. This occurs when the bonding of atoms have approximately equal electronegativity value or equal ability to attract electrons to each side. Nonpolar covalent bond is an example of bond formed with two chlorine atoms and atoms combined. So we have A And of course, we have letter B. All right, so here, so for letter A, that would be polar band between, of course, chlorine and hydrogen. And for letter B, we have non-polar band between two chlorine. So we have here for letter A. So for letter A, we have chlorine is more electronegative than hydrogen. Hence, the polar arrow is directed towards chlorine and the bonding electrons are pulled more strongly towards chlorine. Now for letter B, so we have chlorine and chlorine. Since none of the atoms is more electronegative than the other, the bonding electrons are shared equally. So it's a non-polar. Okay, that is for letter A, it's a polar. It is because chlorine is more electronegativity than hydrogen. Polarity of molecules and molecular geometry. So you just have learned how to predict the type of bond polarity simply by calculating the electronegativity difference of atoms. The next question is, how about of those molecules consisting of more than two atoms, like we have water and we have carbon tetrachloride and we have ammonia and of course, we have carbon dioxide. For polyatomic molecules, both the band polarity and molecular shape determine the overall molecular polarity. In terms of molecular geometry, the valence shell electron pair repulsion theory would help us to determine the spatial arrangement of atoms in a polyatomic molecule. So you can predict the shape of molecular geometry of a substance using following steps. Step 1. Determine the central atom of a molecule. The central atom is the least electronegative element. Step 2. Draw the appropriate Lewis dot structure for the molecule. Step 3. Count the number of bonding pairs of electron and non-bonding or lone pairs around the central atom. 4. Determine the electron pair orientation using the total number of electron pairs. Step 5. Identify the shape of the molecule based on the location of atom. So this figure three different molecular shapes. This is linear, trigonal, bent. We have tetrahedral, trigonal pyramidal, okay, and trigonal bipyramidal and octahedral. Example 1, predict the molecular geometry of BCl3 or this what we call boron trichloride. So step 1, electronegativity of boron is 2.0, electronegativity of chlorine is 3.0. Therefore, B will be the central atom and 3 chlorine are attached to it. By looking at the chemical formula, you will also have an idea that boron will be the central atom and 3 atoms of chlorine are attached to it. So here for step 2, this is boron, and in boron, we have 3 chlorines. Okay, so we attach the 3 chlorines to boron. Step 3. The central atom has 3 electron pairs, 3 bonded pairs, and no lone pair. So let's check if there's lone pair. So we have 2, 4, 6, 8. So single dash is 2 dots, so therefore 8. The octet rule must be 8 dots. So 2, 4, 6, 8. We have 2, 4, 6, 8, 2, 4, 6, 8. So it's equal. There are no lone pair. Step 4, the electron pair orientation for 3 electrons is trigonal planar. Step 5, the molecular shape of boron trichloride is trigonal planar. Another example, predict the molecular geometry, of course, of CHCl3, or this is what we call trichloromethane. So step 1, so you have the electronegativity of carbon is equals to 2.5, electronegativity of hydrogen is equals to 2.1, and electronegativity of chlorine is equals to 3.0. Because the carbon is less electronegativity than chlorine and hydrogen is normally the terminal atom, C must be the central atom. So in step 2, so we have here the molecular formula of the trichloromethane. So we have C here as a central atom, carbon central atom. So we have chlorine and chlorine. We have 3 chlorine and 1 hydrogen. So of course we're going to check. So we have 2, 4, 6, 8. We have 2, 4, 6, 8. We have 2, 4, 6, 8. And we have here the hydrogen. We have 2. In step 3, there are 4 bonding electron pairs. Okay, so we have 1, 2, 3, 4. Step 4, the electron pair orientation for 4 electron pairs is tetrahedral. Step 5, the molecular shape of trichloromethane is linear. Next example, we have predict the molecular geometry of carbon dioxide. Step 1, so we have electronegativity of carbon 2.5, electronegativity of oxygen is 3.0. Therefore, C will be the central atom and 2 oxygen atoms will be attached to it. So you may also use the chemical formula to predict which atom will be the central atom. So step 2, we have here C is the central atom. So we have oxygen to oxygen 2, 4, 6, 8. So 2, 4, 6, 8. We have step 3. For the purpose of determining the position of the bonding pairs, let us count the double bonds as one bonding pair. So therefore, carbon dioxide has 2 bonding pairs of electrons. It talks about double bonds, so 2 bonding of double bonds. So step 4, the electron pair orientation for 2 electron pairs is linear. So the molecular shape of carbon dioxide is linear. Now that you have learned how to determine the molecular geometry, let us now go on our discussion of polarity of molecules based on molecular shape. You may study the diagram below and we will use it as our guide. So we have no and yes. So is this shape symmetrical in 3D? If no, continue. If yes, continue. So we're going to hear. If no, the molecule is polar. If yes, are atoms are all atoms bonded to central atoms the same? So if no, that is polar. If yes, the molecule is non-polar. You must think about a molecule in a 3D according to VSEPR theory. And this is the flow chart to determine if a molecule is polar or non-polar. Going back to our previous examples, let us try to determine the polarity of molecules of BCl3 or boron trichloride and carbon dioxide and CHCl3 trichloromethane. For both BlC3, boron trichloride, and carbon dioxide, the atoms are symmetrically arranged or trigonal, planar, and linear. The attached atoms of the central atom are also the same. So you must also take note that in symmetrical molecule, the sum of the bond dipole is equal to 0 because they cancel out. And the leads of the formation nonpolar molecule, therefore both BCl3 or boron trichloride, carbon dioxide are nonpolar. On the other hand, we have trichloromethane. Although it has a symmetrical arrangement or tetrahedral, the atoms attached to the central atom are not all the same, or 3 chlorine atoms and 1 hydrogen atom. This causes trichloromethane to become a polar molecule. So now let us see if you fully understood our discussion. I want you to try answering the exercises below or our activities. So we have here activity number 1. Okay, identify which molecule is polar and which is nonpolar given the Lewis structure and molecular shapes of the following molecules. So you have 1, 2, 3, and 4 for the molecule, and for the Lewis structure, molecular geometry, and molecular shapes. Another activity, so we're going to fill in the data here. So this is our molecule. We're going to draw the Lewis structure and the difference of electronegativity, the band polarity, the molecule geometry, and the polarity of molecule. So in your own words, differentiate polar and nonpolar covalent bond. What is the electronegativity and how can it be used in determining the polarity of molecules? It is possible for a molecule to have a polar band but have an overall polarity of or nonpolar. Differentiate bonding and non-bonding electrons. Another one, answer the following questions below. 1. Ammonia is a polar molecule while boron trifluoride is a non-polar molecule. Explain the difference in the polarity of these compounds. Number 2. Suppose that AB3E hypothetical molecule is discovered. Predict whether the molecule is polar or non-polar by determining its molecular shape. Note, A corresponds to central atom, B terminal atom, and E is a lone pair or non-bonding electrons. Now for our assessment, so choose the letter of the best answer and write the chosen letter on a separate sheet of paper. So we have here number one. The following molecules have polar covalent bonds except A, ammonia. Okay. We have letter B, carbon disulfide. And we have letter C, we have boron trichloride. And we have letter D, hydrogen bromide. For number two, which of the following bond is most polar? A, H-Cl, B, C-Cl, C, H-H, D, and dash F. 3. What is the molecular shape of CHP3? A. Linear, B. Trigonal planar, C. Trigonal bipyramidal, and D. Tetrahedral. Number 4. Which of the following pairs of atoms are bound by a nonpolar covalent bond? A. NaCl, B. Ca-O, C. P-N, D. C-S. 5. From the given Lewis structure of ammonia, how many non-bonding pairs of electrons are around the central atom? A. 0, B. 1, C. 2, D. 3. 6. Which of the following statement is incorrect? A. Polar covalent bonds can be present in polar molecule. B. Polar covalent bond is present if the electronegativity difference between atoms is equal or less than zero point 0.4. C. Polarity of bond and molecular geometry are the two factors that affect the polarity of molecules. Letter D. Polar band forms when electrons are unequally shared by two atoms in a compound. 7. What is the relative ability of a bonded atom to attract shared pair of electrons? A. Electron affinity, B. Electronegativity, C. Ionization energy, D. Metallic property. 8. Which description below correctly describe polar molecules? A. Polar bands are present. B. The polar bonds are arranged so that they do not cancel. C. Lone pairs on the central atom are arranged so that they do not cancel. D. Lone pairs on the central atom are arranged so that they can be cancelled out. 9. Which of the following molecules is tetrahedral? A. Water, B. Sulfur hexafluoride, we have C. Ammonium, and letter D. Boron tetrafluoride. 10. Which of the following is not true about carbon dioxide? A. Has an electronegative difference of 1.0. B. Polar bond is present. C. Has a linear molecular shape. D. Is a polar molecule. Now for 11 to 15 or 1 to 5, we have true or false. So write true if the statement is correct. Otherwise write false. So number 1, sulfur and oxygen are bound by a polycovalent bond because their electronegative difference value is 1.0. 2. Atoms with high electronegativity have a greater tendency to attract electrons towards themselves. 3. Polarity of molecules are determined both by polarity of bonds and molecular geometry. 4. Among C-Cl, H-Cl, C-H, and Cl-Cl, only Cl is polar. 5. Methyl alcohol is a nonpolar molecule. Now let us check your work. So the answer for number 1 is B, number 2 is D, number 3 is D, number 4 is D, number 5 is B, number 6 is B, number 7 is B, number 8 is C, 9C, 10D, 11 true, or the number 1, 12 true, 13 true, 14 false, and 15 false. Now, for the additional activities, analyze the following statements, determine if each is correct or incorrect, and briefly explain your answer. Write your responses in a separate sheet. Number 1, we have the SiCl4 is a nonpolar molecule, or silicon tetrachloride is a nonpolar molecule. Number 2, we have hydrogen sulfide has a linear molecular geometry. Number 3, we have phosphorus pentafluoride is a polar molecule. Right. Thank you everyone for